In this A-level question here, let us see how to solve the trigonometric equation. Sin x minus 20 equal to 1 by root 2. Since there is a shift here and it is inside the bracket, it is clearly a translation along x-axis. Whenever there is a translation, it is always recommended you address it with an explicit substitution so that you understand what all solutions you should get in, to be valid in the domain. So, let y be x minus 20, which turns the question into a simple sin y is 1 by root 2. Y is sine inverse of 1 by root 2. Being a prominent value, y should be 45. What you get here should always be a principal value, which is a acute angle or a first quadrant solution. Now the knowledge of cos diagram comes into picture here. Sine is the ratio in question, and from cos diagram, sine is positive in quadrants 1 and 2. So, y1 was 45. Second quadrant value is always calculated as 180 minus principal angle, so 135. But y was nowhere in picture to begin with. We had x. If x was between 0 and 360, y, which is x minus 20, should be between minus 20 and 340. A translation doesn't affect the domain much, but regardless, it is always better to do this so that you follow standard set of steps. Now, x1 should be 45 plus 20, which is 65. x2 should be 135 plus 20, which is 155. These two will be the answers to part A. Now, going to part B, cos 3x equal to minus half. Here, this is a stretch along x by a scale factor 1 by 3, which means in place of 1 cosine wave, you have 3. It is compressed. So, obviously, you are bound to get extra solutions. In place where you should have got 2, you will get 6. In place where you should have got 3, you will get 9. Everything is tripled. This definitely warrants a explicit substitution and recalculating domain. Let 3x be y, making cos y minus half. So obviously y, which is thrice x, has values up till 1080. So when we have a negative here, ignore the sign and just take inverse of the actual value. Cos inverse of half is again a prominent value. 60 degree, again principal value. The principal value that we get may or may not be one of the solutions to this given problem. It depends on the trigonometric ratio. Now again, knowledge of cos diagram. Cosine is the given ratio. It is minus, it is negative. Cos is negative. Where? Cos is positive in first and fourth. So it is negative in second and third quadrants. So second quadrant solution, the first solution that we get is calculated as 180 minus 60, which is 120. The third quadrant solution, which is our second solution, should be 180 plus theta. Now, since the periodicity is affected because of the compression, the original period of cos is 360. So, since it is affected, in place of 2 values, we are going to get 6 values, we said. So, the values are bound to repeat every 360 degree. So, this is first round. Now, in the second round, y3 should be 120 plus 360, 480. y4 should be 240 plus 360, 600. Third round. 480 plus another 360, 437, 8614, 840. Finally, y6, 600 plus 360, 960. Now that makes it 6 values. But again, y was nowhere in question to begin with. So let us address a substitution. x1 should be 120 by 3, 40. X2 should be 240 by 3, 80. X3 should be 480 by 3, 160. X4 should be 600 by 3, which is 200. X5 should be 840 by 3, which is 240. Finally, X6 960 by 3, which is a 320. So 40, 80, 160, 200, 240 and 320 are the 6 values to this particular problem. So this is a very commonly asked A-level trigonometric equation solving question. So regardless of what the ratio is or what the sign is, if you follow these set of steps, when there is a transformation especially, the chances of making mistakes are greatly reduced. It makes things crystal clear for the students and helps you identify how many values are there, and easily with these standard set of steps you should be able to solve any trigonometric equation. Hope that helped. I'll see you in another video. Thank you.